This is the screencast for section 2.6, example 2, transforming the reciprocal function. Well, we know the reciprocal function is one of our basic functions from section 1.3. It has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. G of x then, directions. Describe how the graph of the given function can be obtained by transforming the graph of the reciprocal function 1 over x. Identify the horizontal and vertical asymptotes and use limits to describe the corresponding behavior, then sketch the graph. Lots to do. Let's get started. So g of x, if I'm going to make this look like the reciprocal function, I can pull the 2 off to the side and leave that as 2 times 1 over x plus 3. So now I can see the 1 over x part of the function, and I can tell you that the transformations that took place were a horizontal shift left 3 and a vertical stretch by 2 in that order. Alright, so I described the transformations. I need to identify the horizontal and vertical asymptotes. Well, the vertical asymptote used to be at x equals 0, but that vertical asymptote got moved left 3. So now the vertical asymptote is at x equals negative 3 instead of 0. The horizontal asymptote used to be at y equals 0, but my y values changed. They got stretched by 2. Well, 2 times 0 is 0, so I still have a horizontal asymptote at y equals 0. So now I can do a sketch of the function. Let's see, which means I'm going to have at negative 3. So there's my sketch of the function, my new function translated. And I can talk about the end behaviors. Well, since I have a vertical asymptote at x equals negative 3, those limits are going to have x values that both approach negative 3. This one is from the right, and then as we approach negative 3 from the right, the y values go up to infinity. This one down here, the limit of f of x as x approaches negative 3 from the left this time. So we're going to get very close to the value negative 3 on the x-axis, but then our y values are going to go down to negative infinity. Negative infinity. Now we have a horizontal asymptote at y equals 0. And remember, y equals f of x. So I can say that the limit of f of x, I know, will definitely equal 0. Those f of x values are going to 0. X on this situation is coming all the way up to positive infinity to the right. Now on the left, the limit as x approaches negative infinity of f of x is also 0. As we go all the way out to the left, the function is going to approach the horizontal asymptote y, or f of x, equals 0. Now part B is weird. It looks nothing like the reciprocal function. We've got an x in the numerator and an x in the denominator. Well, there's a trick to this. I can do synthetic division, or long division if you prefer, I doubt it, and plug in 2 to the coefficients in the numerator. So I'm going to take 3x minus 7 and use synthetic division to divide by x minus 2. So now I have fraction form that I can use to rewrite h of x in a different way. H of x, 3x minus 7 divided by x minus 2, actually equals 3, remember this is the remainder, this is the constant term, so it's 3 minus 1 that remains to be divided by x minus 2. That now looks like part of the reciprocal function, so I can identify the transformations that took place. To make it even clearer on myself, I'm going to leave the negative sign with the fraction because that's where it goes, and then put the plus 3 at the end. That is a positive 3, so that would say plus 3. Now I can identify the transformations that took place. That is a horizontal shift right 2, then a vertical flip over the x-axis, then a vertical shift up 3. To sketch the graph, the vertical asymptote x equals 0 got changed. My x values got shifted right 2. So now my vertical asymptote is going to be at positive 2. Let's see, the function got flipped over the x-axis, so I'll keep that in mind when I'm graphing. And there was a vertical shift up 3. So now my horizontal asymptote that was y equals 0, the y values got shifted up 3. Now remember, there was a vertical flip, so instead of the top right containing the graph, the bottom right is going to contain the graph because it got all flipped over. So that's what my graph of 3x minus 7 divided by x minus 2 looks like. Pretty amazing. Now, we need to write these end behaviors. So I have a vertical asymptote at x equals 2. So the limit of f of x as x approaches to this end is going from the left is going to equal up to positive infinity. So the x values are coming in towards 2 from the left. The y values, or f of x values, are going up to positive infinity. Down here, the limit of f of x as x approaches 2 on the x-axis but coming in from the right. The y values are going to go all the way down to negative infinity. Now the horizontal asymptote, we said, takes place at now y equals 3. So each of these end behaviors, the f of x values are going to approach 3, the y value of the asymptote. So the limit of f of x as x approaches, now this end goes all the way out to the right to positive infinity, is going to equal 3. So as x goes out to infinity, f of x levels off, goes no higher than 3. On the left side here, the limit of f of x as x approaches going to negative infinity on the x-axis. Now looking at the y-axis, these values are going to level off at 3, which makes sense because that's the horizontal asymptote. The now try problem for example 2 is number 5. Oh good, they gave us one of the easy ones. I don't have to divide. Haha. Describe how the graph of the given function, oh, same directions. Okay, here we go. So first there is a horizontal shift right 3. So now I can graph this. The only transformation that took place was a horizontal shift right 3. Well, since vertical asymptotes are x equals, all the x values got added by 3. So instead of the vertical asymptote at x equals 0, now the vertical asymptote is going to be at x equals 3. The y values didn't change. There are no vertical transformations taking place, so the horizontal asymptote is still at y equals 0. So I'm going to graph this like the reciprocal function, approaching both asymptotes. Alright, so now let's name those end behaviors. I've got plenty of room, so I'm going to use it. Let's work with the horizontal asymptote first. The horizontal asymptote is at y equals 0. So both of these are going to have the limit of f of x as, the f of x values are going to approach 0. Those y values are leveling off at y equals 0 as x goes all the way out to the right to positive infinity. On the other side, the limit of f of x as x approaches, okay, so that's going to be left to negative infinity. The y values are also approaching 0. You do not need to put from the bottom or from the top, just in case you were wondering that question. Now the vertical asymptote is at x equals 3. So the limit of f of x as x approaches 3 is going to be the x approaching value. 3 is the x approaching value. We're coming in from the right this time, so it's going to be 3 plus equals positive infinity, going all the way up to positive infinity. Now down here, the limit of f of x as x approaches 3 from the left equals, this time, negative infinity. As we're coming in from the left on approaching 3 on the x-axis, the y-axis is going all the way down to infinity.